Okay, good, perfect. Alrighty, I guess it's about time to start. Welcome back after the break. I hope you enjoyed your meals. We'll start with something very light after lunch. So basically, next level Redis with Spring, especially Spring Data. And what we're gonna do in the next 50 minutes is we'll have a look at the basic Redis commands, what Redis is, typical Redis setups, how you can interact with Redis, and how Spring and Spring Data help you integrate your Java application with the Redis store. Okay. About myself, my name is Christoph Strobl. I work for Pivotal, and there I'm in the Spring Data team. Basically responsible for the store abstractions for MongoDB, Redis, a little bit of Solr. I do JPA if I have to, not too much of it, of course, a little bit of key value and all that stuff. But let's jump right into it. So what is Redis actually? Redis is the remote directory server and was invented about 7 or 8 years ago by Salvatore Sanfilippo, who lives in Sicily, and he back the time when he invented it had a need. He needed a fast store, key value store, namely that he could interact with over the network. And so he came up with this little C program and called it Redis in short. And Redis, its main purpose is it serves as a key value store. But there, over the time, people used it for many more things different to just the main key value store where we have a key and the value associated with it, but also it serves as a cache. It is often used for queues. It's used for distributed logs. It's used as a session store. I mean, take Spring Session for it. It has an integration with Redis, so you can store your session data inside of Redis. You can use it for analytics using bit operations and all that stuff. And since the 3.2 release, it also has support for geo-indexing and geolocation data in there. And to serve all these use cases, Redis has a set of data structures built within. So the most basic data structures are strings. Then we got lists, we got hashes, we got sets, we got sorted sets, and a structure called hyperlog, which is especially fast in calculating unique things. So imagine you want to have a page counter for your web application that counts by IP address. You can use hyperlog as a fast data structure to just keep track of unique page visits per IP address over the day and time and what have you. On top of that, Redis offers additional features like pops up, public subscribe mechanism. It has sort of transactions, but we'll come to that a little later, what it means to have transactions in Redis. And it also allows you to execute Lua scripts on the server and manipulate data there with Lua script. That's basically all about Redis. So for us being on the same page, we'll have just a short look on basic Redis data types, the ones we talked about already, and how you can use them, especially with the Redis commands, and what you can achieve issuing those commands against the server. Let's get started. So the most basic and trivial data structure is obviously strings, and those are used for storing especially keys and values. So both of them are inside of Redis. It's just byte arrays. So Redis doesn't really care what you put in there, but for us humans, it's likely that we use human readable strings. So we got a key and a value, and we can set the value of a key using the set command. And of course, very trivial, we can get the value back for the key using the get command. We can also call getSet, which basically gives us the value stored for the key and at the same time sets the value for the key in an atomic operation on the server. We can use a set and X, which is a set if not exists. So if the value already exists, we won't have it set. It will be untouched. Only if it didn't exist. We can ask for the length of a string, pretty obvious. We can append something to a string. We can somehow get a range out of it, or set a range, which would be some substring operations, basically, if you are thinking in Java. And there is a special case in Redis. Though the data structure is called strings, there is a special meaning to strings that happen to be numbers. Those can be integer or floating point numbers, because on those you can call operations like increment, which would increment the stuff by 1. Increment by, giving a non-floating number, would increment the value there by this, and increment by float if you want to increment the floating point number. And of course, you can do it the other way around by just calling decrease by and decrease by float. Okay, moving on to the Redis lists. So given the family Stark here, we got Aria, we got John, we got Bran, and potentially some others. Lists in Redis, of course, allow duplicates. Would be hard in here, but obviously you could append another Aria at the end of the list. And yeah, you can push something to the list on the left side, calling lpush, and you can just get it away from the list and retrieve it, calling lpop on the left side. The same applies to the right side of the list. At the end, you can right push and right pop that stuff. You can ask for the number of elements within the data structure issuing the llang command. And of course, you can set the value at a given position in the list using lset. You can retrieve it. Obviously, you can insert at a certain position. So you see there is a big similarity between the data structure we have in Redis and the ones we have already in Java, because that's the nature of the data structure. You can get a range out of the list by calling lrange, and we can remove something from the list using positive and negative offsets that indicate how many elements to remove from either the right or the left end of the list. Yeah, we got sets. Sets, same as in Java, doesn't allow duplicates, so this is much more appropriate for the Lannisters, let's say. And we can add something to a set, calling sadd, and you already recognize a pattern in here. So the Redis commands for lists all start with L, while those for sets start with S. I mean, the pattern isn't really going through, but it's sort of a pattern. Okay, you can use spop to retrieve a random element from the list. You can ask for all the elements of the set, You can ask how many elements are within the set stored. You can ask if a certain element is a member of the set. And of course, you can remove something from the list, issuing sram, because poor Tywin got unfortunately shot by his son, so he's no longer there. Sorry for that. Though he was a bastard, I guess, so he deserved it. We got sorted sets in Redis, calling csets. And yeah, taking again the Lannisters, sorting them by, let's say, age in ascending order. We got Tywin, Cersei, Jaime, Tyrion, and we can add something to the list, calling the set command. We can get a range out of it. We can reverse the range we want to get out of it. So the commands get a little bit tricky in here. So we got set ref range. And there are even more commands that allow you to use lexical ordering. Those get really tricky, so you could use something like set ref range by lex, what have you. So those commands somehow prolong themselves by nature. I can show you some of them later on. And of course, you can order them by score, which would be the index number in there within the sorted set. And you can reverse that stuff, and you can ask how many are there using the setCard command. You can count that stuff, and you can ask for a certain score, which would be the position in the set for using the setScore command. Great, and you can increase the score if you want to. And of course, remove that stuff. We got hashes. Here we have Daenerys, and we stored all her properties, let's say, as key values, as a hash inside a hash. And so we got the last name, Targaryen. She's obviously a queen, and she has a pet, or 3 of them, dragons, 3 dragons as a pet. And we can set something calling the hset command, which would set a key within the hash inside. We can use the hget command to get the value back. We can use hmset to set multiple values at the same time and get them back. We can ask for the number of elements we got within the hash using the hlang command. We can remove something calling hdel, and we can get the keys, the values, and of course both of them calling hgetall. The Geo commands, those have been added in the 3.2 version, so if you happen to use it, by the way, anyone using Redis in here already? Not too many, 2 obviously, okay. So for those of you who don't use it, which is the majority, Redis has the Geo command since the 3.2 version, which allows you to add, which reuses the cset data structure basically, to store geo information inside a cset. So it reuses this cset data structure, but has different commands to it so that Redis knows how to calculate all that stuff. So basically this core that we had before for the cset is calculated out of the even and odd bits of the geos of the geo position that you put into it. And I hope I don't get it wrong. It was the even bits make of the longitude and the odd bits are for the latitude. And there has been a talk by Salvatore how he uses that stuff to create tiny little squares and all that, and so on, to allow geo indexing and geo querying on that stuff. I always get a headache when I watch it, but maybe one of you wants to give it a try. It's out there on YouTube for, I guess it was last year's Redis conference. It's worth watching, definitely. Okay. Having that said, you basically can add a geolocation with the given name and longitude latitude pairs to the cset using the geoadd command. You can ask for the position that you added given using the given name and the geopause command. You can calculate the distance between 2 already existing points in the cset using geodist. You can ask for the geohash representation of that position within the set using geohash, so it will give you that nice little geohash string out of it. And of course you can ask for all the points that are within a given radius. You can ask for all points that are within a given radius where the center is one of the already existing elements within the cset. And of course you can remove stuff from the cset. I mean, in this case King's Landing was pretty much destroyed, so you can use sedram to just remove that stuff. Sedram in this case, because we are reusing the cset, and Salvatore didn't want to add a new command which isn't obviously necessary to do something in there, so it's sedram, which is more or less a geolocation remove. Well, you just have to remember that with Spring Data we offer you something that's called georam or delete and all that stuff, so that you don't have to think about that there is a cset behind that stuff. And now moving on to transactions will be the last part of this Redis introduction. Transactions in Redis happen to be a little bit tricky because Redis is, as some of you might know, single-threaded. So everything you push to the server is basically executed in one thread, and that's how all those operations by nature become atomic, because only one request can be handled at a time. And transactions are somehow like you issue a multi-command which puts the server in a queuing mode, then you then you go on, push all the commands you want to have, and as return value those aren't executed immediately, but they get queued on server side. So you basically call set with a key and a value, and it gets queued, and then on the same connection to the server you call get with the key, which gets also queued and doesn't return anything immediately. And then you get the option to either call exec, which will execute all the commands in a row that got queued before. So and it will give you back all the result values from the operations you could queued before. So in this case, it would give you OK for the set command and give you the value for the key you just set. Or you just go on and discard that stuff and everything is fine and nothing happened. Transactions, however, only work in a single node environment and cannot be used in a clustered environment because they don't work over the borders of a single server. So be aware of that when using transactions and potentially want to when you potentially want to upgrade to a clustered environment. So those won't work there. Just keep it in mind. This brings us to the more or less typical Redis setups. So when you get started with Redis, what you do is you basically go to the Redis website, download that stuff. Hopefully you're on a Linux environment, so because you just have to make it on you build that stuff on your own machine, and then you spin up a server, standalone server. Let's see how that looks. There's something I want to show you additionally, because when you go to the Redis website, there is, besides the download and all that stuff, you can have a look at the command, and you get a list of commands down here. And what is really unique for Redis is that it gives you the runtime behavior in here for each and every command. So you get the time complexity O log n in this case for the geoposition command. And this is something I'm not really used to or familiar with from other data stores, but that's really unique for Redis. And many of those operations have O from 1, which is pretty fast. So Salvatore really cares about performance, and that thing is really fast, and that's probably one of the reasons why it's so popular. Okay, I've already downloaded that stuff onto my machine, and I've already built it. And once we get started with a single server, there we just go to the Redis directory, and there is something called Redis server. And I started the server, and it's on port 6379. And it has a PID and all that stuff. It's running. There is nothing in there. I have already started it comes with the Redis CLI. Let me just stop that one. Hello. Thank you. There is also the command line interface Redis CLI. You can start it up. It will by default connect to the local host and the port. And then you can just go on and play around with Redis by calling, let's say, set key 1 is voxed. Set key 2 is Vienna. Okay, then you can ask for the keys. How many keys do we have? Okay, we have 2 keys in here, and those are key 2 and key 1. And of course, we can get key 1 and get key 2, obviously. And we can can get multiple keys at once. Mget multiple get. Oops. Get key 1, key 2, and we get in the order that we requested the keys, we will get back all the values. So it's pretty easy, I'd say, to get started with Redis. The commands are trivial, those are well documented what they do, and you just go ahead and play around with Redis. No big deal in there. Okay. But the thing with a single node is always what happens to your application if that node dies. Boom. Well, in the worst case, your application will be dead for some time until someone goes there and restarts the server, and hopefully you got all that stuff persisted to disk so that all the data is reloaded. Not the thing you potentially want to have. So what you potentially want to have is something called a high availability cluster and all that stuff. So you just start adding at first additional servers, slaves to your master server that hold copies of the original data so that you can faster fail over to that stuff. And the failover won't, in this case, won't not happen automatically. So again, there would be a human needed, or at least a script needed, that watches that stuff and notifies everyone that this server just died, and someone has to promote one of the slaves to master and all that stuff. So it's really a pain, and therefore for a couple of years ago, Sentinel was introduced. So Sentinel is basically a Redis server that behaves a little bit different. So it watches all your master-slave configuration with a heartbeat, and then checks if the master goes down, and then there is a master election going on, and the clients get notified automatically that the master is down and that the new master has been elected, and that this particular server, let's say the upper one there, is now the new master. So your application might fail, but it won't be too long, depending on the configuration you have and that Sentinel provides for how long it takes to promote a new master. And yeah, so this is much more convenient. And you got all your key space basically still on one server, and it's not distributed, so it's not spread around a cluster in that case. So it's pretty easy to interact with. Okay, since Redis 3, we got something called Redis cluster. So Redis cluster is different from this high availability scenario that we just talked about with the sentinels. Because in Redis cluster, there is no such thing as a sentinel, but there are master servers and there are slaves. And the whole cluster constantly talks to each other, so that all nodes at the time know which nodes are master nodes, which are slaves, which nodes are no longer available, and the cluster does this master election on its own. However, a cluster has an additional feature, and this is automatic sharding. So as we saw before with the Sentinel, there is only one master and slaves, and all the data is on one of those servers at the time. In Redis cluster, data is sharded, and it's sharded in a way so that the cluster has 16,384 slots. So a slot is a logical partition of the cluster. Each slot can have as many keys as you want in there, but all slots have to be covered by the cluster at all time. If one of these slots isn't covered by the cluster, because all master nodes and slaves that serve a specific slot range are down, then your whole cluster is dead until all slots are served again and the servers are restarted. So please keep that in mind. Okay, let's have a look at Redis cluster and how it feels to work with a Redis cluster. We got a really nice tool since the 3.2 version, which is the create cluster tool. Before that, you had to set up the cluster manually, assigning all slots manually using potentially some Ruby script. This has gotten much easier in the 3.2 version, so we just can use the utility that comes already with the Redis distribution called create cluster, and we just start the cluster in here. Okay, so we're starting 3 nodes, 3 masters, and a slave to each master. We use the Redis CLI using the -c flag for, okay, let's move to cluster mode. And we give it the port for the initial node to connect with. So with the -p command, so we're connecting to basically the first node in the cluster. Okay, now that we just started the cluster, we can call cluster nodes, okay, to see how many nodes do we have in the cluster at this moment. And there is only one node currently, so the nodes are still not connected to each other. So these are 6 independent Redis instances at the moment. So we have to create a cluster configuration, and this is the step that you had to do manually before, or that you might have to do manually if you're managing a larger cluster than the one I have here. Okay, so we can use cluster create to create a cluster, and this basically assigns the master nodes with master and assigns all the slots in there. So you see this one covers how many slots it covers, and this the slot range that is covered by each master. Then we got the slaves that are for those, and we have to accept that stuff. So we type yes in there. Now we send the cluster meet commands and all that stuff and assign the slots. And once it's done, it hopefully says all the slots are covered. And now when we go back and ask the Redis server again to tell us how the cluster looked like with the cluster nodes command, well, there you go. It basically tells us, okay, there is a master node that serves the slot range. There is a slave for that master, and so on and so forth. So you see all that stuff is there. And now we can go on and can again add stuff to the Redis cluster by calling set key1 boxed. Okay, that worked pretty fine. So set key2 Vienna. Oops. Now you see something that I talked before. This is the automatic sharding. So what you see here is basically when we tried to set the key 2 to Vienna, Redis told us that the slot the key 2 maps to isn't covered by the server we sent the request to. So we got redirected to another server that serves this exact slot range. And if we now have a look at the slot, cluster key slot for key 2, you see this is 12,422, and that should be covered by server 3 in here, because it's in that range. Okay, pretty nice so far. And then we can go on and get the key back. That works pretty nicely. We can get the key 2 back, get redirected again because it isn't served by the server that we sent the request to, and then we can call mget key1 key 2, and boom, that didn't work as it did in the single node environment and as it would have worked in a Redis Sentinel environment. And this is because Redis doesn't allow cross-slot requests within the cluster. So if you want to retrieve multiple keys, or there are other operations that involve more than one key, you have to make sure that all those keys that you have within a single command map to the very same slot, not the same machine physically, but really to the same slot on the server. Otherwise, Redis will give you an error. So what you could basically do is you could pin a key to a certain slot by doing, let's say, set, and then you use curly brackets, key1 and bar. So you put it inside those curly brackets, and what Redis does, it basically looks for the innermost curly brackets, takes the value in there, and calculates the slot from the value in there. So in this case, it would just be key1, and get redirected, and I could call mget key1, and this again key1, and that worked because it's the same slot. Pretty nice. Okay, let's move on and see what happens if we, let's say, use the keys command. Because you already know using keys in a single node environment just gives you a list of all the keys. In the cluster environment, it will just give you all the keys from the server that you're talking to, not necessarily all the keys within your cluster. So if you want to know all the keys that you have, you would have to go to each and every node and ask it for the keys it has. So much for that. Just keep that in mind. Okay, that's some of the issues you will face when using Redis cluster, but still it's pretty fast, and once you know about the limitations, it's really easy to work with. And of course, we in the Spring team, and especially in the Spring Data team, try to make data access for you as easy as possible and as convenient as possible. So there, Spring Data Redis will help you deal with the special cases that might appear in a Redis cluster environment. So let's start off with a few Spring Data Redis basics. What we have is a template. For those of you familiar with Spring will know the templating stuff that we have in there for JDBC template and all that stuff. So it's basically the template does the resource management and exception translation into Spring's exception hierarchy. The template works with a connection factory because in the Java world we have a different set of Redis drivers. So there is no official Redis driver out there, but there is a bunch of community projects, and so we have this abstraction of a connection factory that gives you a Redis a connection to a single node server, to a Redis Sentinel environment, or to a cluster using a cluster connection. And we got several serializers for that stuff because, as you know, Redis doesn't really care about what the data looks like that you put in there. So you can basically serialize your stuff using a JDK serializer, string serializer, or some Jackson. And below the connection, we got the Redis drivers. The ones we're going to support in the future are Redis and Redis. There are 2 more drivers, but we'll drop support with the next release for those 2 because they are unmaintained for years now, and it's gotten a pain to work around all the limitations those drivers have. So Redis and Redis are the drivers we are going forward with. Okay, so let's have a short look at how Spring Data Redis works in a clustered environment. We got something here. So this is just a normal Spring Boot test application. We connect to the cluster that we just set up on the port. We set up the connection factory. So we get the connection factory auto wired here. We retrieve a cluster connection from the connection factory. And just in setup, we just remove everything so that we have a fresh installation. And then we go on and use the keys command, and what we expect to do is we expect the implementation to take care that we really get all the keys from our cluster. So what happens behind the scenes is basically we detect that this is a command that has to be executed on all nodes within the cluster, at least on all master nodes. We go there asynchronously, talk to each and every master, execute the command there, aggregate the results, and once finished we return it to you. Okay, let me just run that stuff in here to prove that it works. So it connects to the cluster, splits up and collects the results, and everything is there. So we get the keys that are distributed on 2 nodes within the same collection. Of course, you can read all keys from a single node. So what you would do in this case is you would basically go here and tell the connection that you want the keys from a specific node. This is different to the Java drivers that are out on the internet there, because they normally only talk to one server, and we just took the opposite approach. So we basically talk to all servers, and if you want to talk to a specific one, you name the one you want to talk to at the moment, because in the other scenario it might be, depending on the last command that you executed, a random server that you potentially don't know about. Well, not that stuff we want to have. Okay, so you can read all keys from a single cluster node, which no, this is, I shouldn't have switched to IntelliJ lately. Now I mix up all these shortcuts. Okay. And of course, we support executing those cross-lot commands where we set the key 1, key 2, and we expect them, if we issue a multiple get command, that we don't get an error or something like that, but we just get yes, no. Damn you. This one. We expect them to be returned in the correct order that we issued the stuff, because as we go there asynchronously, it might happen that the results come in different order, and we reorder that stuff, and so that we keep in sync with the contract the Redis documentation has for you out there. Okay, I got to hurry up a little bit to finish in time. So that's more or less the basics for Redis connections with Spring and the cluster handling. I want to talk about a little bit more advanced topics now. Something called the object hash mapping. This isn't really new. There have been projects in Ruby around for years by now, but we just recently picked those up and used those for Later on, implementing Spring Data repositories, which you might already know from MongoDB and JP and all that stuff, on top of Redis. But we need object hash mapping for that, because normally we live in a rather complex world, not only having keys and values, but having, let's say, a person object that's a first name, last name, a complex address within there. And when you want to store that stuff inside of Redis, one approach you might want to choose is just flatten it out, make it a JSON, throw it into Redis as a string. So you call set, give it a key, and then just put in there the JSON string. Valid approach, works pretty nice, works fast. You just have to go through the overhead of JSON serialization, but that's not too much. And pretty efficient by now. But the thing is, all you can now do with that JSON string is basically you can get it back and put it into the serializer back and deserialize it again. I wouldn't recommend trying to alter the string that you just put into Redis for an update or so, but just go through the whole serialization process again and then update the value in there. Another approach would be the object hash mapping, which basically goes here and flattens out all the properties that you have in your domain model so that they fit into a hash, into a Redis hash. So what you would have then is basically you would have the ID, the first name, and for complex objects you would then just by point separate the properties. So you would have address country and then the nor to indicate that this is a complex object or a complex nested path, and you use the domain meta model to just map it back on the deserialization. The thing that you now get with that is you can just retrieve everything, hgetAll, just the same as with the get command, but you could also just use hget, the ID and last name. This should be hmget, but no, don't worry about it. Which would be something like a projection. So you just take out a few elements that you want to have depending on your need of data. You could ask if there exists a property within the hash, if that matters to you. And of course, you can do something like a partial update by just setting a certain key in the hash. Let's say the last name is then no longer John Snow, but John Doe, because you had a typo in there or whatever. So you have partial updates and don't have to serialize, deserialize the entire object over and over again. Okay, and for Spring Data, we offer something called an object hash mapper, which takes the Spring Data domain model. So it inspects your domain types and caches and that stuff. And inspect your domain type, finds out about all the properties and those types, and then just does all the hash mapping for you. All you need is an object hash mapper within your configuration. Doesn't take any special arguments, and then you just go on, create an address. Let's say it's Winterfell in the north, and the person is Jon Snow, who's a boy, obviously, who lives in Winterfell, not for so long, but at least for some time. And then you just go on and create a hash, and then you just set the hash, and then you can retrieve it back. So basically you read all the values there, put it into hash mapper, and get the person from that. Okay. This one, no. Damn you. So that obviously works. And if we now look how the data is, so we could call keys, I guess. Yes, there is this one. hgetAll, give it the key. So this is how the representation within Redis would look like there. Please notice there is this underscore class attribute that we render in there. This is basically more or less the same that Jackson does. It's just an indicator to know the root type, so you can map that stuff back, because you could put in there, could give the mapper just an interface or something like that, and we need to store the exact class to just read it back. Nice, that worked so far. So let's talk a little bit about secondary indexes, because in some cases you finding entities by their key, unique key, might not be enough. So think about a session store where you potentially have a user associated with multiple sessions within different applications, and you got a single sign-on or what have you. And so the key would be the email, and you want to retrieve all these sessions for this particular email. Then you might end up with secondary indexes, because those data structures help you to identify data not only via their primary key, so to speak. So let's take the example from before, and what we now do is we use a set to create those indexes. So we would have a set with the key first name John, which would take all persons, their first name is John, and we put in the ID of the entity we just saved, which would look something like this. So we put in 1, 2, 3 into the first set. Now we would index the last name just the same way, all people that are named Snow. And what we now can do is we can use the sinter command, set intersect, of those two sets, and would retrieve the IDs of all people who were named Jon Snow, obviously. And then we could use just hgetAll to retrieve that stuff. Or we can use sunion to create all people, to create an OR query. So all people that are John or Snow, what have you. So it's pretty easy to just determine entities and their IDs. And with Spring Data Redis, we support that by using the Redis repositories. So we got a CRUD repository, and we can just add an annotation down there. So we just add index to first name and add index to last name. You can set this up programmatically, but for slides, it's better to have those annotations. So this will basically tell the Spring Data Redis implementation to create an index for those properties. Also works on nested properties, so you could put something into address and address city, and it would get indexed as well. But for here, we just call a repository save, give it the Jon Snow, and what it does, it just uses the object hash mapper that we have in place to create the hash, and it detects the indexed annotations and the values there, and it sets up the sets for you for use. It also can handle something called partial update, so you can call repository update, give it a partial update that sets the first name, because you had a typo in there. And what this does, it detects that there is an index on that first name. So it will set, not also alt, it would first set the value within the hash that you have, and it would then go on and remove the old value from the already indexed stuff and add it to a new index or an existing one, depending on if there's already someone with, if there's already an index there. So that happens behind the scenes. So it will detect indexes, it will detect the values that you already stored, it will remove them and take care of all the index updates for you. Of course, this takes a little bit of time, so think about it when you use it. Think about the number of properties you want to index, and because every index operation just grows the meta model and the code path you have to run through for every operation you do. And of course, you can then have derived queries on properties that you have indexed. So Spring Data Redis repositories allow you to just declare a method in the interface by find by first name and last name, which doesn't require you to have an implementation. So we'll derive the query for you, and once you then call repo find by first name and last name, it will create the sinter command for the indexes with the values, and then just get all the IDs from the repository, and later on fetch the values using the hgetAll command. Okay, we got a few more minutes, so I'll just quickly show you how that works. So this is the repositories. This is just a Spring Boot application. We enable the Redis repositories. We've got the person repository in here. It should be declared on there. This is the person repository. We got here the find by first name and last name method. We got the historic family again, which is then just set up. via the flash test user. So we got find by multiple properties using AND. So we just execute the find by first name and last name. So we're just searching Aria Stark. Yay! I remember the key, the shortcut. Yes. Okay, that worked. Obviously, nice. We can use the same stuff for OR. So we got find by last name, first name or last name. It should work as well. Damn you. Yes. Okay. So since we only got 5 minutes left, I just wanted to point out something that you might not be aware of. Redis supports something called key space events since the 3.0 version. So what we have in Spring Data Redis, basically we allow you to listen to those key space events and get notified whenever a key expires. And you could have something in your domain model that is called time to live. You annotate the property and this will tell Redis to just expire that entity after some time. This is useful especially for sessions. Let's say you have a session that may only last 30 minutes. So you set the time to live to 30 minutes and the entry will be gone after some time. Now if you have the key space events enabled, your application will get notified via an Spring application event that this particular session just expired, and it will give you a shadow copy of the object that expired. The trick is Redis tells you that a key has expired after it already deleted the key. So the data is already gone when you receive the event. But if you have a time to live defined, we'll keep track of it, create a shadow copy for you if you have the key space events enabled. Keep all the modifications for you in sync, and then return you the shadow copy so that you know which values exactly expired and not just the key, because who knows what this key might have been before. Okay, to give you a little outlook on what to expect for later versions of the project. Okay, there just right before, there is some more stuff you can do. You can add references so that you don't have to copy all the values. If you got nested elements and all that stuff, you can add custom conversions for types. So let's say you want to convert the address into a JSON object. If it's nested in your domain model, you can do so. Just register a custom conversion using a JSON serializer, and all that stuff will happen for you. You can have spell-based indexing if you want to. And now let's move on to what's next. Next will be geo indexes, so that you have Spring Data repositories that you can have a geo index set up on a point, which would allow you then to just have, let's say, a derived find by address location near you, give it a point and a distance, and it will execute the georadius command for you given the distance and what have you, and just return you all of the results. And more interesting, we're busy working on Spring Data 2.0 release. We have a first milestone out there, and our focus is on not only the upgrade, the Java baseline upgrade to Java 8, but also the integration for the reactive programming model in there. And so what we'll have is we will have reactive commands in Redis for MongoDB as well, and for Cassandra in the first place. And we will make use of Project Reactor, which is something like RxJava on steroids, let's call it that way. And what you see in here is basically the return type. So we would have Flux and Mono as return types, where Mono would be something like an RxJava 2 maybe, and a Flux would be something like an observable if you want to. So a Flux can give you more elements, and the Mono might be 0 or 1 element. And this is how the API will potentially look like. You'll see more in milestone 2 of that stuff. If you want to give milestone 1 already a try, don't care about Spring Data Redis in general, but take MongoDB if you're more familiar with that. Just give the reactive approach within the Spring Data projects a try, and I would really encourage you to give us feedback on what you think about it, how it is to use, so that we can incorporate that stuff before we go GA, which will happen later this year. A second milestone will hopefully be out by May, which will include the Java 8 baseline upgrade so far. I guess I finished just in time. So thanks for coming. Enjoy the rest of the conference. If you got questions, I'll be around for an hour or so. Just come by and yeah, have a nice day. Thanks for listening.